Today we're going to talk about methane, the other greenhouse gas, by Pablo Ruby, Justin Abshire, and Vincenzo.
You may already know the role that carbon plays on Earth and how it is a contributor to the greenhouse effect. Yet the other significant and recently rising greenhouse contributor, methane, is often not given as much attention. Methane is a colorless and odorless greenhouse gas that is very present in our biosphere, both occurring naturally and from increased human activities. These human impacts on the environment include industrial livestock production, fossil fuel combustion, biomass burning, and waste management. The largest methane sink is the atmosphere, which sources primarily from man-made emissions, wetlands, and now the melting and depressurization of methane hydrates that are increased by rising global temperatures.
Methane has a significant presence in the atmosphere and has several properties which make it a potent greenhouse gas, such as its high specific heat capacity and its maximum potency after release. The most prominent greenhouse gases in the atmosphere include carbon dioxide, methane, nitrous oxide, halogen-containing gases, tropospheric ozone, and water vapor. According to the Environmental Protection Agency in the US, the environment currently contains less methane than a greenhouse gas such as carbon dioxide, which makes up about 65% of global greenhouse gases. However, even small releases of methane into the atmosphere pose a threat to the environment as it is better at trapping heat in the atmosphere than carbon dioxide. Methane in its first 20 years is 82 times more potent than carbon dioxide, according to the Environmental Defense Fund, sourcing primarily from industrial emissions, as is carbon dioxide.
Greenhouse gases, or gases, in the atmosphere are ones that absorb infrared radiation, essentially trapping heat and warming the planet. The most concerning aspect of increased levels of methane is that it enhances the greenhouse effect, which is defined as the increase of atmospheric greenhouse gases from human-based activities, such as from burning fossil fuels or industrialized agriculture. Visible light, ultraviolet, infrared radiation, and other forms of radiation constantly bombard Earth's atmosphere. Ultraviolet has shorter wavelengths and higher energy compared to infrared radiation, which instead has longer wavelengths and a generally weaker energy level. The process of the greenhouse effect is as follows. Solar radiation reaches the Earth in the atmosphere, reflects some 30% of the solar radiation, the shorter wavelengths, back into space, while the other 70%, the longer wavelength, is absorbed by the atmosphere and landed in the oceans. As they hit, they release heat in the form of infrared radiation, which then would pass through the atmosphere and escape into space. However, some of the heat is instead trapped by the greenhouse gases and in turn heats the Earth. The enhanced greenhouse effect causes more gases to be released into the atmosphere, which then in turn traps more heat, causing global temperatures to rise. And as explored before, methane poses just as relevant as a threat to our environment as carbon dioxide.
Before we mention the overall effect of methane on the biosphere, it is important to mention some of the evidence we have that shows that this effect exists. Ice core samples from Antarctica have showed very strong correlation between increased air temperature and levels of methane gas. There is also evidence of massive releases of methane going back over 250 million years ago that have affected both Earth's climate and the extinction of many species. Similar to how carbon dioxide's environmental impact is well known and well documented, the same is mostly true for methane gas, because they share properties such as high specific heat capacities, which categorizes it as a contributor to the greenhouse effect as a greenhouse gas. Increased atmospheric temperatures from increased levels of methane directly contribute to the adverse effects of climate change. Methane is also known to be released into the atmosphere more from oceans and permafrost during periods of warming than previously thought, where other producers of methane emissions include wetlands and landfills, where methane is produced from the anaerobic decomposition of organic matter. Additionally, large amounts of methane are trapped in ice as it warms or depressurizes. These methane hydrates break down, water and methane gas is produced, and this gas escapes into the atmosphere. This creates a positive feedback loop because more of this expelled methane increases global ocean temperatures. More methane is released, making methane hydrates one of the most significant contributors to this eventual warming of the planet.
Increased methane in the hydrosphere is known to damage marine organisms, as gas can penetrate a fish's gills and disturb its functional systems. Damage to many primary consumers from increased methane can significantly hurt the ability for secondary and tertiary consumers to find enough food, which will also affect humans, as approximately 3 billion people rely on seafood for their primary source of protein, according to the World Life Fund for Nature. There are also many wildlife species, such as a mule deer or desert tortoise, that have had declining populations due to increased amounts of methane in the atmosphere. According to a study done by the National Wildlife Federation, new energy developments have contributed to migration barriers, toxic ingestion, habitat loss, hurting the mule deer and desert tortoise, who have declined by 50% and 90% respectively. Once methane is in the atmosphere, it is extremely difficult to break it down quickly, making the best way to prevent its further release is to stop it from its source. One solution is for people to reduce the amount of products they buy from industrial livestock production and rice farming, because both of these human activities contribute to the amount of methane in the atmosphere. Reducing methane waste is also an essential step to limiting the damage facing the biosphere, as the government can take actions to propose standards of how methane is to be handled. Some other solutions include the introduction of new environmental regulations that puts limits on the total amount of methane that corporations can burn to release energy. Additionally, a tax could also be placed on methane, which may disincentivize people from buying products such as red meat, as industrial livestock production from cows is a main producer of carbon in the atmosphere. These regulations and limits on the amount of methane that can be used will also decrease the amount of methane hydrates that break down, hopefully limiting the adverse effects of having more methane in the atmosphere and of the climate change in general.